All right, this is welcome to Module 2. We're going to be learning all about transformations in Module 2. So your warm-up for today was to go ahead and plot these points on the coordinate graph, and this is on page 1. You'll be using those in a little bit. Okay, so the second thing I wanted you to notice is that a transformer gets its name transformer from the word transformation. And so if you watch this quick video, you can see Optimus Prime goes through a series of transformations to transform between.
This is why I use Grammarly.
Oh, you know, we got to watch this Grammarly commercial real quick. There we go. So what you'll see here are reflections. You can see rotations. You just saw those pieces rotate. You saw translation, which is to slide. Okay. And this shape has virtual symmetry, except for the different weapons. And now you can see those same transformations occur again, where he goes back to the truck. Pretty awesome, I know. So, let's see, that was a video within a video. What different transformations did you see? Well, you probably saw everything but a dilation. So now these notes are not in your packet. You just want to chill and listen. So a transformation is an operation that maps or moves a figure in a plane to a new position. The figure in its original position is called the pre-image. And when we mark a pre-image, you just, call it what it is. And then when you move the figure after a transformation, that's called the image. And you'll notice the image gets a little prime symbol. That's this symbol right here is what we call the prime symbol, which is interesting, which might be why Optimus is called Optimus Prime. I don't know, because it's the image after a series of transformations. And there are 5 transformations. We're basically going to talk about reflections, translations, rotations, and dilations. Dilation would be the only thing you probably didn't see when Optimus Prime changed. All right, so there are 4 kinds of transformations. And if you want, you can write them down on a separate sheet of paper. We're going to start with reflection. Then I believe we talk about, rotation. Then it's a translation. And last is a dilation. And this should also take you back to like 8th grade math. So let's go ahead and look at the pictures below, and you can see the different rules that occur. So this one right here would be what we call a reflection. This would be a translation because it's just a slide. So this you should think mirror. This you should think slide. That's translate. Rotate is a turn. So you should get an angle out of it. And change in size, that would be a dilation. So think of your eyes, that's a dilation. When you take a picture, when you take a selfie, that's also a dilation. All right, so this is like a little introductory activity. You should have already plotted these points as your warm-up. And you're going to complete pages 1 through 3. I'm not going to show you all the answers to numbers 2 and 3 at this point, but I will show you how to set it up. So what you're going to do is you're going to observe what happens to your coordinate points to see which kind of transformation, which one of these cats basically occurred in your picture. So the first thing I'm going to do is I'm going to graph these points. Let's see, -9, 8 is here. And you always want to label it. Remember that pre-image just gets -4, 4 is here. -1, 6 is here. Oh, wow, I made a wonderful triangle. So there's this is what we call my pre-image. All right. Now it tells me at the bottom what to do. So now I'm going to transform point A in my triangle. So my original point A was at -9, 8. And I'm going to add 5 to the x-coordinate, and I'm going to subtract 7 from the y-coordinate, and my new A prime is at -4, comma 1. So -4, 1 is here, A prime. Now I'm going to perform the new operation to B and C. So my original B was at -4, 4. I'm going to add 5 and subtract 7. So my new B prime is at 1, -3. B prime, because that's my post image. And I'm going to do the same thing to C. So my original C was at -1, 6. That's my pre-image. I'm going to add 5 to the X and subtract 7 from the Y. So C prime is now at 4, -1. And what I should notice is I have exactly the same shape, but what happened is and all the things are in the same orientation, but what happened is my figure just slid down. And so when you have a slide that occurs, in at least one sentence, I would have to say that my pre-image slid onto my new image, so this would be a translation. Okay? And you're going to go ahead and look at number 2 on page 2 and number 3 on page 3 to see which kind of transformations you get for those examples as well. And you should get one of as a rotation and one as a reflection. So today specifically what we're going to talk about is a reflection. And all reflections actually have a line of reflection. In many cases we're going to talk about the x-axis and the y-axis as being our lines of reflection. But it's basically the middle line in any figure. So it kind of separates the pre-image to the image. And if we're looking at the swan, there would be a line of symmetry right here. And what you should notice is that, for example, the eyeball in the swan is going to hit exactly the same distance away, and it's going to hit at a 90-degree angle from the line of symmetry. And that should always occur. And this young lady here, you can draw a line of symmetry down the middle. And you should notice that her thumb is going to be exactly the same distance from the line of symmetry, and it should hit at a 90-degree angle. And the same with her toes, so the same thing occurs. When we're looking at this Spalding ball, there is no line of symmetry there. And here you can see, again, you could do the y-axis or the x-axis and see two different lines of symmetry. In most cases, we're going to talk about the x-axis and the y-axis. So let's look at some examples and the rule that occurs. So this is on page 4. So we're going to discover the rule. So it says a reflection across the y-axis. Well, the first thing I would always do is highlight line of reflection. So in this case, I'm going to highlight the y-axis because it says y-axis. All right. Second is flip points across line, same distance away at 90-degree. All right, so whatever. All right, so I'm going to flip it away. It's going to be 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. So this is my new R. And what you'll notice is if I flip it, it does make a 90-degree angle. All right, T is going to say exactly where it is because it can't be flipped. And S is 5 away, so I'm going to count 5 over here, and there's S prime. And what I should see is a bow tie because it's the exact flip. Now, the third thing is we're going to compare our coordinates. Compare coordinates. All right, so S was at -5, 5, and S prime is at 5, 5. R, we're not going to compare T because obviously it stays the same, is at -5, 2. R prime is at 5, 2. What you should notice is that the x coordinate changes. You see that? It went from negative to positive. But the y coordinate stays the same. So how do we write that as a rule? We write it as negative x, y. So reflect across the y-axis, y stays, x changes. And that's always going to work, no matter what. And that's the rule. Y stays the same, x changes. Let's look at a second example. We're going to follow those same steps. I'm not going to rewrite them. However, this time we're going to flip across the x-axis. So I'm going to highlight the x-axis. This C is going to go straight down 2, 1, 2, so I'm going to put it right here. The D is going to go up here, and the B is going to go up 2. So this one's kind of flipping on itself, which makes it look a little bit confusing, but y'all smart people, so you can handle it. So let's make a prediction. If when we flip across the y-axis, the y stays the same, my prediction is that x is going to stay the same, and y is going to change sign. All right, so let's see if our prediction is true. So let's compare coordinates. So B is at -4, -2, and B prime, check it out, is at -4, +2. So it did work out. The x is going to stay the same, and the y is going to change. So we write that as x, comma, -y. Let's just be sure. Let's compare C as well. So C is at -3, 2. And C prime is now at -3, -2. So if it was positive, it went to negative. If it was negative, it changed to positive. So that's the rule for when you reflect across the x-axis. You might want to write that down so you have those notes next to number 3. Okay, number 5. Let's go ahead and flip to number 5. Now we're going to reflect across the y equals x line. So if you remember this from back in the day, the y equals x line is actually a diagonal line that cuts the graph this way. Okay? So this is the y equals x line. So once again, you're going to want to flip across the y equals x line, but remember it has to be at a perpendicular angle. So it's going to kind of go to here. All right, and this one, so S is at 1, 2, 3, 3, 1, and what's going to happen is here's your new S prime is at 1, 3. So what happens is your x and your y coordinate flip-flop. So flip-flop coordinates. So y comes first and then x. So u is at 0, 2. So if you flip it across, you should see that it's going to come down here. U prime, because it's got to make a 90-degree angle. And it's at 2, 0. And then this one's going to go here. I think that's T. So what you should see is your shade should go this way, which makes sense. Your other option is to take a piece of patty paper and literally trace the line and flip it. And I can show you how to do that when I come back. All right, so T, I'm sorry, just plain T, is at all right, so I'm going to stop there. And hold on. All right, so T is at 5, 0. And it's going to go, T prime is at 0, 5. Now, or vice versa, actually. These are flip-flopped. So I'm going to stop here, but there is a second video. The second video should only be a couple minutes long, but I'm going to take you through how to do Khan Academy and everything. So you should be able to finish pages 1 through 5 today in class, plus your Khan Academies.